Good evening. Today we're going to be taking a look at a topic in mathematics known as systems of equations. More specifically, we're going to answer the question, how can we use graphs to find solutions to systems of equations? So first and foremost, let's address this from the get-go. What is a system of equation? Well, essentially it's just any set of two or more equations, right? So for instance, we might consider an example like, we'll take two linear equations to get us started. Y is equal to 2x plus 1, right? That's a line with a slope of 2 and a y-intercept of 1. And maybe y is equal to negative 2/3 x minus 1, right? A slope of negative 2/3 and a y-intercept of negative 1, right? So we have two equations here, and when we have these two equations as a system, we want to actually solve them simultaneously, right? So what does that mean? Well, each of these equations, right? Let's take, for instance, y is equal to 2x plus 1, right? That's going to be a line on a graph, right? As we said, it's going to be a line with a slope, and I'll show you a picture of this in just a second, but it's a line with a slope of 2 and a y-intercept intersecting the graph at the point 0, 1. And when we write this line and when we graph this line, what we're essentially saying is there is going to be this huge infinite set of pairs of values, x's and y's, that make this equation true. Right? So for instance, if we look at x is equal to 0 and y is equal to 1, that pair of values makes this equation true, right? And we can demonstrate that. If we plug in 1 for y and 0 for x, and then we do out the arithmetic, we have 1 is equal to 1, right? It makes that equation true. And so 0, 1 is an example of a pair of an x value and a y value that makes that true. Likewise, we could pick something like negative 1/2 comma 0, right? And this will do the same sort of thing, because if we plug in 0 for y, that's going to give us 0 equal to, and if we plug in negative 1/2 for x, we'll have 2 times negative 1/2 plus 1. And again, if we do out the arithmetic here, we've got a 0 on the left. 2 times negative 1/2 gives us negative 1. Negative 1 plus 1 gives us 0. And we have 0 is equal to 0, which of course is true. So when we have a graph of a line, what we're doing is we're representing all of the possible pairs that would make this equation true, all of the possible pairs of x and y that would make this true, right? And that will similarly work for negative 2/3 x minus 1. So for instance, we can pick a few points like 0, negative 1, for instance, and negative 3/2 comma 0 would be two examples of points that make this second equation true. Now, each of those are fine on their own, but when we solve a system of equations, we want to look for the points that satisfy both of them at the same time. So an x and a y that is true for equation number 1 and is also true for equation number 2. Now, graphs can be really helpful in this, because if we come over here and we take a look at the graph of these two lines, right, we can see in red here that y is equal to 2x plus 1 is represented by this red line, right? And every pair of x and y values, right, as I scroll along this line, you'll see every pair, right? So 0.51 and 2.02, that's an x and a y value that satisfies that equation. It makes it true if you were to plug those in. All of these represent the values that work for that first equation. Right? And then in our blue line here, we've got y is equal to negative 2/3 x minus 1. And so all of these values, right, for example, negative 3.03 as an x value and 1.02 as a y value, all of those, if you plug them in, would make negative 2/3 x minus 1 equal to y. And that would make that second equation true. So if we want to find the points that make both of them true at the same time, right? Which spot along this line is going to be true for both, is going to satisfy both of these equations? Well, it's going to be the point where they overlap, right? The piece that they literally share visually, right? Their intersection, right? And so we can look here and say, okay, on this graph, these two lines intersect at the point negative 0.75, negative 0.5, or in other words, if you like fractions, negative 3/4 and negative 1/2. And so just by looking at this graph, we can see from their intersection what the solution to that system of equations is, right? Because again, this point here, negative 0.75 and negative 0.5, is the point on the line, the pair of x and y values that both of these two equations share. And that's what we're looking for when we're looking for a solution to a system of equations. This was an excellent question. Thank you for submitting this question. If you guys have any other questions, please feel free to submit them by commenting below. I hope you found this helpful, and I hope you have a great rest of your day.